In this video, we are going to discuss one more problem on specific energy calculation. Let me read out the question for you. The specific energy for a 3 meter wide channel is to be 3 Newton meter per Newton. What should be the maximum possible discharge? Okay, what can be the maximum discharge value in that channel? See here, I told you earlier, discharge is going to be maximum when the specific energy is minimum. When the specific energy is minimum, this flow is called as critical flow. So in this question, since he is asking you to calculate the maximum possible discharge, the specific energy that is given in the question has to be E minimum. Okay, so this is the this problem is to be solved considering the flow as critical flow. Okay, remember. So since he is asking you to find out the maximum possible discharge, Q maximum, as we know, when Q is equals to Q max, E equals to minimum, you need to consider this as a critical flow. So let us find out. So what is the general equation for Q? Q is equals to area into velocity. That's it. And what is the Q max? Q max is nothing but QC, right? Critical velocity. What will be the equation? B into, this is the rectangular channel again, Q into YC into VC. So I need to find out what is YC. I need to find out what is VC. Of course, you know what is VC. VC is equals to root over G into YC. E is equals to cube root of Q square by G. So initially I gave you an equation for E minimum, right? What is the equation for E minimum? E minimum is equals to 3 by 2 YC. So YC is equals to 2 by 3 into E minimum. So what is YC? 2 by 3 into E minimum 3. 3 get cancelled, 2. So critical depth is 2. So now what is the velocity? Velocity is equals to root over G into YC. So VC is equals to root over 9.81 into 2. Root over, what do you get? 19 point something, right? So if you find out the root, it will be 4.43 meter per second. So now what is the equation for maximum discharge? Area into velocity, or B into YC into VC. So what is B? 3 meter wide channel. What is YC? 2 into discharge, velocity 4.43. So 3 into 2 into 4.43. You get 26.58. So this is the critical or the maximum discharge in this channel. Let us discuss another problem on specific energy. Okay, from unit 1. So let me read out the question for you. Water flows at a steady and uniform depth of 2 meter in an open channel. So the depth of the water is 2 meter in a rectangular cross section area having base width of 5 meter. So this is the base width 5 meter and laid at a slope of 1 in 1000. Yes, it is desired to obtain critical flow in this channel by providing a hump in the bed. So this is the main condition here. What he wanted to do is the flow is going with a depth of 2 meter, and what he wanted to do is he wants to convert this flow into a critical flow. So how can you do that? So we know that when the flow is critical, the depth of the flow is YC, critical depth. So he wants to make the flow to go with critical depth or critical velocity. So how can you do that? You can do it with the help of a hump. Okay, hump of the bed. So this is a hump. You can, hump is nothing but something, anything, okay, that is resting on the ground. Okay, it can be a stone, it can be a masonry work, anything. Okay, I'm going to show you a video at the end of this problem. When you put this hump over here at this place, what's happening is the flow is converting into critical flow. Okay, that is what he wants to do. But the problem here is he wants to calculate the height of the hump required. Okay, see here, what is the height of the hump? Small h. He wants to find that small h. If see here, if the hump is lesser than what is required, the flow is not going to be a critical flow. It is still going to be subcritical. And what happens if you provide a larger hump? The flow will convert into supercritical flow. Okay, but he wants to have a critical flow. So you have to find out for that exact case what is the h. So it is very simple. Okay, what I'm going to do is I'm going to find out what is the yc and what is the vc square by 2g and what should be the minimum energy. Okay, I find out E minimum. And now I find out Y, of course, he given in the question Y. I am going to find out what is V square by 2G. Now I am going to get E. E is equals to Y plus V square by 2G. Isn't it right? So now, as you can see in this figure, this capital E minus of E minimum is what is the height of the hump required. Okay. So now simply I need to find out what is the VC, YZ and V and Y. Okay, let us find out the critical case first. Okay, and this is the dimensions you can find out from these given data. Depth is 2 meter and width is 5 meter. So you can find out what is the area B into Y and perimeter B plus 2Y and R is this. I'm using this Chegis equation for finding out the discharge, and this is the relation between Manning's and Chegis equation. Of course, he has given the rugosity coefficient or Manning's coefficient, but I know what is the relation between Manning's coefficient and Chegis coefficient right here. So I can use this relation and use the discharge equation of Chegis of Chegis. So now when I calculate the discharge, what I'm going to get is from Chegis equation, this term is nothing but C. This is the discharge. From the discharge, I'm going to calculate small q, and from small q, I'm going to find out YC. So I found out what is YC. Now E minimum. E minimum is equals to 3 by 2 into 1.055 this. So what is the E minimum? 1.5825. So at this critical case, at a hump నేను పెట్టిన చోట what is the energy, specific energy of the fluid? That is E minimum, and E minimum equals to 1.5825. Now let us find out the specific energy at the first section, this section here. I know already the depth is 2 meter. So let us find out what is the capital V. So discharge is already calculated in this from this equation. What is this equation? C into root over RS. Okay, you can use that equation, and I got 1.696 as the velocity. Velocity equals to 1.696. Okay, of course I know the discharge, right? I know the discharge. From this you can find out discharge is not going to vary. So now calculate the velocity from this Manning's equation or Chegis equation, and that is what I got 1.696, and substituting that you get energy at this particular state. So now E minus of E minimum will give you the height of the hump required. So E minus E minimum equals to 0.5645. So whatever the obstruction or the hump you are placing there, that has to be the height of 0.5645. When that height is this value, then that flow is going to be critical flow. So the first question here is, we have a channel here. A 8 wide channel conveys 15 meter cube per second of water at a depth of 1.2 meter. So this is discharge and this is the width B of the channel. It is a rectangular channel, as you can see. Okay, isn't it? How can I say that? If it is a trapezoidal channel, it is going to have a side slope. Calculate specific energy of the flowing water. So I need to calculate E. This is the first thing. And second one, you have to calculate critical depth, critical velocity, and minimum specific energy. I mean, you need to calculate what is YC, VC, and E minimum. You know these equations, right? So it is not a big deal. And Froude number and state whether the flow is supercritical or subcritical. You know what is the equation for Froude number? Fr is equals to V by root over Gy. Okay. So now let us write the given data. So width of the channel 8, discharge Q, and depth of the flow 1.2 meter as given here. So first thing, what is specific energy? Specific energy is equals to E equals to Y plus V square by 2G. I mean Y plus what is V? Q by A. Therefore I can write this equation as Q square by 2G A square. So now I can further write this as Y plus Q square by 2G B square Y square. Of course, this is a rectangle channel, I told you, right? So I have taken the area as B into Y. And again, I am writing this E is equals to Y plus small q square by 2G Y square. So in order to calculate the specific energy, I need to know what is Y. Of course, I know what is Y, 1.2 meter. And Q, I don't know. So let us find out Q. Small q, right? So what is the small q? Discharge per unit width, total discharge by width of the channel B. So 15 is the discharge given in the question and width of the channel is 8. So 1.875 meter cube per second per meter. Okay, discharge per meter length. Okay, so this is the value of Q. So you can find out E. But at the same time, in the second part, I need to calculate the critical depth and everything, right? Critical velocity. So I am trying to find out the velocity of the flow also now itself. I can use later. The average velocity of the flow is, as you know, this is the area of the channel. So velocity equals to discharge by area, 15 by 8 into 1.2, and that is 1.5625 meter per second. So now let us find out the specific energy E. Specific energy E is equals to, of course, you can use any of these equations. Okay, I have used Y plus Q square by 2G Y square. You can use this equation or this equation. Okay, that's okay. So substitute the value, you are going to get 1.324 meter. Remember, I told you that specific energy is the energy per unit weight of the channel, I mean water. So the units are going to be meter. Now critical depth. What is the critical depth equation? Y is equals to cube root of q square by g. I know what is this value of small q, 1.875. Substitute that, you will get 0.71 meter per second as the critical depth. And the critical velocity, v is equals to root over gyc, that equals to 2.64 meter per second. And also we have derived for the equation for E minimum. E minimum and eppudu and vasthundi 3 by 2 yc. So 3 by 2 into yc already calculated 0.71. Put that value here and you are going to get 1.065 meter. Okay, so you can find out in that way also. Now third one, what is the third one? You need to find out the Froude number and you have to classify the flow. And okay, here there is a chance that you make a mistake here. So you know that Froude number is equals to 1 for critical flow, but here the depth is 1.2. I mean, let me give you here. See here, what is the critical depth of the flow? 0.71 meter per second. What is the actual depth of the flow? 1.2. Isn't it right? See here from the question, depth of the flow is 1.2, depth of water is 1.2. అంటే ఇప్పుడు ఏంటి, డెప్త్ అని అక్కడ 1.2 అంటున్నట్టు క్రిటికల్ డెప్త్ ఏమో 0.71 అంటే it does not mean that the flow has to go always at critical depth. Okay, so the flow in a channel can be anything. Okay, but the reason for finding out the critical depth is based on critical depth you are going to find out what kind of flow it is. Okay, for every channel there is going to be a yc, and the depth of the flow in every channel is not going to be yc, it is going to be something y, some y value. Okay, but we are finding out this critical velocity, I mean we are finding out what should be the depth of the flow, what should be the depth of the flow in order that channel carry a critical discharge or critical velocity flow. Okay, in order to classify that flow, that's it. Okay, so you calculate yc equals to 0.71, that does not mean the flow is going with 0.71, it is actually going with the depth of 1.2 itself. But when that the depth 1.2 decreases to 0.71, then that flow in that channel is going to be critical flow. Okay, that is what I wanted to tell you here. Okay, different channels will have critical depth different, right? So that is the reason for finding out it. So now in calculation of Froude number you have to put the actual velocity and discharge value, I mean by value. So this is the discharge calculated in the first slide, and this is the depth 0.455. So Froude number is less than 1, so you can say this is a subcritical flow. And remember, subcritical flow is also called as tranquil state flow or tranquil flow. Okay, so as you can see, y is greater than yc. As I told you, if the flow is subcritical, the depth of the flow is greater than the yc, and vc is going to be less than, v is going to be less than vc, and y is going to be greater than yc for subcritical. So that is proven here again.